So I'm just going to share my screen. And tonight we are using Zoom for like a bit of a chat and just a little, I've got just a small presentation. And then we're going to hop over to coding rooms and try out some of the things that we have learned. Has everyone used coding rooms here?
No, that's primarily why I'm here. I use Replit because we just have Chromebooks, and so it's a zero load, and
Okay.
it works, right?
Okay, so none of you have used coding rooms yet?
No.
Okay, well, maybe then the first thing we should do is jump over to coding rooms, and I can just show you around coding rooms, and then we'll get into the Python introduction. So if I give you this code here, this link, I'm going to post it into the Zoom chat. Are you all using a PC or a laptop or? Yeah. So if you click on that link, it should open up a browser that you connect to my classroom on coding rooms, and you'll be able to type in your name and then just join the class. Just let me know if that doesn't work for you. It may ask you to like sign up, but you don't need to. You can just click continue and then just put your name in. It might come up with like anonymous. You can keep an anonymous name if you want, or just put your name in there.
It's asking for an email address.
Okay, did you click on sign up or did you click continue? If you close it back down, just click the link one more time, and then it'll have two options, sign up or continue, and just click continue. Does that work, John?
Yes, it did. Thank you.
And then just put your name in and then click OK, and you should join the classroom. Hey, there you go. I can see you all on. All right, I'm going to share my screen and show you what I see from the teacher's perspective. Are you guys teaching online right now, or are you back in school?
Hybrid.
So you're hybrid. So you're all hybrid?
I'm 100% online.
All right, okay. So I came across coding rooms when we were 100% online. That's when we started using it for our school. I felt it was actually quite a good software that helped my students and me as a teacher. That was something we were struggling with. Theory-wise, it was really easy to do over Zoom because you could share PowerPoints. But when it came to programming, when they needed that help and support, I couldn't give it to them. Which is why we went into got coding rooms. So let me just talk you through this as a teacher's perspective. So hopefully you've seen my screen. And there's on your screen, you should be able to see up the top presentation and workspace. So if you just look at yours, you should be able to see those two areas. The workspace is your place where you type your program code and then you can run it. So my workspace is over here on the right. This is some code I've been just plugging in ready for our Python introduction tonight. So I can run that and it will run it down in the console. So that's your workspace. If you then on your left, you'll see presentation, and that's the teacher's in the way, that's like the teacher's whiteboard. So if all the classroom are joined right now, you can see I've got 3 students on, which are you guys. And then as I'm typing over here, you should be able to see it on your screen under the presentation window. Can you just put your thumbs up if you can see me typing? Welcome from the UK. So if you had like 30 students on, they could all see me typing this. So this is good for modeling solutions, or you've just talked about variables or something, and you are then demoing to the students how to do things. And then what they can do is then they can take your code and copy it and paste it over to their workspace, and then they can start editing it and run it. Or they can also, if you wanted to do a collaboration with a few students, they can all click on the presentation window and start coding as well. I can't remember if I've turned that feature off for this lesson, because someone just tried to click on my presentation window and type something in. See if it works. No, it's not working. Okay, I think I turned that feature off, sorry. So there is a collaboration feature where you can, and that's quite good because it comes up with a name. So as you type in a piece of code, your name will be tagged to it. So that's really good for like sharing and collaborating in the classroom. Anyway, this is the like best feature that I love about coding rooms is the student workspace. So this is great to see how your students are doing. So for remote teaching, this is extremely useful. So right now I can see Rosie's code over here. I can also see John's code, and I can see Greg's code. Now, as you are typing and running your code, so if you just want to click on my workspace and type some code, you'll be able to see that I can then see exactly what you are doing from my screen. So, so if you'll just type like print or just write a print statement.
What do you want to type print?
Yeah, just type print and say, I don't know, just put.
Is there a personal workspace?
Yeah, just put it into my workspace. Yeah.
Yeah, I already did that.
Yeah, so I can see yours done there. All right, so if you just look on my Zoom right now, my Zoom shared screen, I can see as John is typing, I can see what he's doing. And I can see Greg, I can see your code you've put in there. And I can see Rosie's screen as well, like just a coding part. That's quite useful. So then if a student flags up and says, my code's not running, then I can just go and have a look at their code and say, oh, hey, there's an error on line 3. And I can even help them and click on their screen and I can change it for them. So for example, if Greg had an error on line 6, I could just go in and, I could even write a little comment and say, change this line of code to, etc., etc. And on Greg's screen, he'll be able to see that live, and then he can change that. So any questions so far on that? No? Okay.
So obviously classes are not this small. So how do you switch? So if you have 20.
Yeah, that's a great question. So
much window space.
Yeah, so up
full monitor.
No, so up here you've got you can select like your window sizes, how many you want on the screen. I've set it to if you had like 30, you could do 10. But then there's a pop-out screen, so you can have like different tabs. So I could have like 10 students on this tab, and then maybe another 10 on another tab. So I can have can have different tabs with like different sizes.
I like that. Yeah, I like that.
Yeah, it is a pretty good thing, especially if you've got large classrooms. The largest class I've got is 25. So
tabs make sense. Then you can put 4 on a thing and scroll through. Yeah.
Yeah.
You only have to scroll through 4. Yeah.
Yeah. No, just on like debugging mode. So if on the left here, so I'm just showing you on Zoom right now. I've got your names there, and if there is an error on your code, so I can just look at this list on the left, and it'll come up and say, John's got an error, and it'll like flag up with like a red dot. It'll also tell me how active you are. So if there's a student, so right now it's like, for example, Anonymous Llama, which is Greg, he's been inactive for 3 minutes. So as a teacher, like if you're looking at that list, you can, and there's a student who's been inactive for 10 minutes, then that's kind of flagging something up to you. Either they've gone off and had a snack, or they're sleeping on the desk, or something's not right. So you can target them and say, hey, what's going on? Do you need any help? And give them that additional support. So that's a really good feature as well, to see how active they are. If they've got error on their code, then it'll pop up here as well. So yeah, that there is the student workspaces. Any other questions? No. I'll just show you an additional coding rooms feature where we've got. So I'll show you this. So the way I teach programming is I have a lot of independent tasks for them to do online. So I would like teach them a theory lesson and about programming and programming concepts, and then for like a few lessons they would have a range of tasks that they would just crack on with, and they would submit it and it would get marked for them. So I'm just going to show you that really quick. So if I went into my year 10, and here's all my challenges. So the students would log in and they would click on a challenge, one of the tasks. Let's say, for example, they clicked on the simple adder challenge. Let me show you the student view. So if I click on the student preview, this is what the students would see. So it says, hey, here's the challenge. They got to do this. It gives you a demonstration. And then when they're ready, you just click open assignment. So the student then would try to program this in Python. I've given them a bit of scaffolding here just to help them, with the commenting side of things. So take two inputs. So they would try that and add the two together and then output. So this is preset. You can change this and you can set it up any way you want. So the student then would program over here on the right. And once it's working, they would then submit it. So over here where I'm pointing, they would then submit it, and it would then mark and grade their work. So I've submitted the code. It should give me a X because I haven't really done anything, and it's saying this, I failed that. I've given 0%. So as a teacher then, you can look at your grade book and you can see, so here's my 10A class. Oh, let's go for 10C. Okay, let's go test class. And you can see like all your students here. I think my students are actually under my other class. Anyway, if you click on here, you can be able to see all your students on the list here, and on the right, you can then see their grade for the submission that they've done. So that's quite a good feature. That's independent work that the students would go and do, and they would then submit and then just keep working through the assignments. And then as they're doing that, I can then have an overview and have the data to show me how they are doing, if they need any additional support, etc. So that there is, actually, I really find it's reduced my teacher workload because it's got auto grading on there. I can just sit back and have an overview, and there's no marking. So that's quite a good feature. Any questions on that side of things?
When you say auto grading, what is it looking for? Is it looking for a predefined output for a predefined input? I mean, or is it?
Yeah, so it would look for, let me
used?
show you that.
Is it looking for keywords in the code?
Yeah, I wonder if I've set this one up. Yeah, so this it's called a test bench, so you can set up. So these are the inputs that I'm going to program to put into their code. So I've got 5 and 12, and the expected output would be 17. So when they submit, the auto grader will put into their code 5 and 17, and then it would expect 17. If it gets that output, then it would give them the 100 points that I've got up here. If they don't get 17, then it would give them this feedback that you would write in here. So you could play around with the auto grader.
What about resolution? If you have ints or doubles, how does it play with that?
You could do ints and doubles. You have to, the more complex the programs come, then you have to really spell out to them in the program specification how they should write their inputs and how they should um, set their outputs. But I think that's a good principle to teach them anyway, to follow the specification that they've been given.
Mm-hmm.
So as I teach my students, because as they go to industry, they need to be able to follow the program specification exactly as they've been given it by their employer or by their team. And this, so that's a good little practice for them that I get
Right.
around the autograder.
Right, but you know how kids are. They don't read. So
Yeah,
if you say
you're
want
right.
2 decimal points and the autograder gives them 8, so it's going to kick it out as an error.
Yeah, it will. Yeah, that has happened to me. I always put in this feedback on the test failure. So if it does fail, or I could then say, hey, don't forget to check the specification, and they can resubmit. It doesn't matter. They can go back, and if they've got an 8 out of 10, then go back and try again, and they could just submit as many times as they like.
Yeah, is that infinite resubmits, or do you
Yes.
give them two out of
Yeah,
3
it's
and every?
infinite. Yeah, you can see then, like as a teacher, you can see all the their submits, and you can check if it's if they've done like 100 submits. You could have a chat with them about that and find
Yeah.
out how, maybe what the problem is. And to be honest, it's probably good that they have submitted 100 times or multiple times, because that's how they learn. They submit.
Right. Yeah, that's nothing wrong with 2-3 submits. It's when they get to 100, you're like, what are you doing?
Yeah, you're right.
Right. What do you do about cheating? So as we all know, they can cut and paste. How do you count keystrokes? Do you measure time? What do you do?
Oh, that's a great question. So I'm wondering if I can show you on here.
Because they'll have one smart kid and 4 that copy, right? They just cut and paste, cut and paste.
Yeah.
It's all too easy, right? Obviously, the variable names when they all use x1 and x2, you're like, yeah,
Yeah, so
creative
this
and
is
different.
I've submitted 3 times here. This is a test one. So if I went into this one here, you can see like there's a history button here, and you can go back. So you could clearly see that was copy and pasted by me. Yeah, because all of a sudden it went from
0
this,
lines, 13 lines. Yeah.
2, and then in like a second they've got like a full piece of code. So this is a real good feature as well, the check in the timeline. So really you'd want to see like line by line. So as you click this, you'd want to see a line and a deleted.
Can you see that? Yeah. So you have to drill down on each one. You can't see that as a whole and see how.
No, you'd have to drill down.
There's no bar graph that says, okay, they did 3 challenges, and on average they spent, let's say, 3 minutes per, and that's all.
No, but that's a really good feature request that we could put in. I do like that idea, actually.
Because you said, you're going to give them a bunch of challenges, because what you want to really do, right, is teach for about 15 minutes, give them a bunch of challenges, let's say 5 to 10, and obviously the high achievers will do 10, the middle of the road will do 5, and then you walk around and you find the ones that can't get out of the blocks, right? They're still stuck in the first or second one, and you go help those 2 or 3 kids get out of the blocks, if you will, so that they can complete at least a couple.
Yeah, I completely agree. I do like that idea. What I will do, coding rooms are quite good at taking feedback from us teachers and implementing it. So I think that's a really good idea. And also, is it Svetlana? Sorry if I said your name wrong. You've also mentioned the same thing on the Zoom chat, and I think it's a good idea. That's something that would be useful, wouldn't it? To see how long they took, and you can clearly see then if it's taken them like 10 seconds for each assignment, then there's something wrong. They cheated. So
especially when all the variable names are the same and the code length's exactly the 14 lines. Like you could do it in a little fewer or more. Yeah. And so do you break the thing, I guess, with the auto grader? I guess you just break it down in really, really tiny chunks. So you just test for one thing. You don't do multiple steps. where you say step A, then step B, then step C. You make each one individual challenge.
You can, I think you can have different checks, like you can do different checks and give them different points for different checks.
Yeah.
Now, if you wanted to, we have, like I've got loads of Python challenges on. I've got about 100, over 100 Python challenges that get harder and harder. And they've all got auto-graded setup on there. So if you did want to start using coding rooms and you wanted my Python assignments, then you could just ask coding rooms to give you Geraint's Python challenges, and they can pull them over to you. They've also got JavaScript on there that you already set up with auto grading, and also they've got their own Python stuff as well. That's I've created my set, and they've also got a set that you can use. So I think in general, that's kind of like an overview of coding rooms. So we've got the student workspaces where you could do live programming and give them support, and looking at their code that they're typing. It tells you if anyone's struggling or how long they've been inactive. And then you've got then the independent coding side to that. If you wanted to teach programming live, Coding Rooms also has a Zoom, well, not Zoom, but a video feature built into it. So you don't need to use Zoom and then Coding Rooms. You could just give them the Coding Rooms link, and you could have a webcam and you could share your screen just like you do on Zoom. So it can just be in one place. So yeah.
Can you push out your code to all of the your students from something you may have done on the fly, or do you have to prepare everything in advance and then create templates for them, which like your starter code?
Yeah. So if you were to do a certain lesson and you knew that everyone needed this code, when they join the class, you can have it set up so that code is ready in their workspace.
So they already have the starter code.
Yeah. So you can have because when you all joined, you should have seen just print hello world. This is Python 3.
Right.
You can have it set up so that they'll be able to see. Maybe you'll have like a template or something there for them.
And how often can you push those out? Because I tend to push out about 5 of these little challenges like this, especially as they go through, right? So you might have 2 at the beginning just as a refresh from last time, and then 3 for the new lesson.
Yeah. So I've never pushed out during a live lesson. The way I would do it is on my presentation mode, I would just get them to like copy the code over and paste it into their area.
From your presentation into the student space. Okay,
yeah, that's kind of the idea of the presentation windows. They can just select everything, right click, copy, and then paste it into their place, and off they go.
That works.
Yeah, that's the way I've been doing it. So I'm like, hey, here's the code, copy it over, and then they would just copy and paste and do that.
Yeah.
All right. What time are we? 1:30. So I'm going to get into some Python stuff unless anyone's got any coding room questions. Okay. All right. Let me. So yeah, at this stage, like I said, we're just going to learn the basics of Python. So feel free to stick around, or you're welcome to go. And if you do leave at any time, it's really nice to meet you guys, and thank you for joining. So Python, just a little bit of a little background to Python. It's released in 1991. It's another thing that came from Britain, which is always is a good thing, because a lot of good things came from Britain. Unfortunately, that seems to have stopped, and now it's coming out of America and China. So, so Britain was the forefront of computer science, and Python came from Britain. So that's a good thing. And it was named after Monty Python, which was a comedy TV show like that was on the TV here back in the day. So that's where the name came from. It's used by a lot of companies. So it's quite a powerful programming language. And something that's really good about it, it runs everywhere. You could just, as long as you got the Python installed on your machine, you can run it on most architectures. And so it's platform independent. So that's also a really good thing with Python. IDLE is the integrated development environment that comes with Python. It's kind of what was used originally. And it comes with two modes, interactive mode and the script mode. The interactive mode is mainly for playing around and testing things out. And the script mode is where you put your programs that you would like to save and use elsewhere. So that's kind of just a super quick introduction into Python and sort of history. So I've kind of thought about three sort of areas that I think are important. When Coding Rooms asked me to do the session and they said that it was for beginners, I was kind of thinking, well, what would I teach my students at the very start of their Python experience? And there's a big debate in the computer science teaching world, especially here in the UK, is about that the first program the students learn are Hello World, like print Hello World. And apparently that's not the best thing to teach them. I don't want to get into the debate on that, but I always think that it's good to learn variables first, and the constructs and procedures and functions. They are like the three areas that I think are very good to learn, because as they learn those, then they can start learning about the print functions and all that. So we're going to look at variables quickly, then we're going to look at constructs, and then we're going to look at procedures and functions. And for each area, we're just going to pop over to Coding Rooms that we've already joined and just try out some of those things. So variables, the way that you could think of them are like containers for storing data values. Don't get too technical about it, but you just think of it like a box that you give a name, and you can give it a type, and then you give it a value. And that box can be then called at any time if it's within scope, and you can change and update the value throughout your code. So the naming is very important, and we have like a set rule. So these are the rules. It has to be consistent. You have to be careful how you name it. So spacing, variable names should not have a space in them. Use an underscore or a camel case. So for example, you can see here for total money, you would name it total underscore money or total all lowercase, and then you do the camel case with a capital M, and that's good practice. And that's, I would call them one of the variable rules. And digits, variable names should not start with a digit. That's another sort of basic rule that we have. So down here, you can see some examples of this. L is a poor choice. It has no meaning. So that's another important concept, is that it needs, you need a meaning to the variable. So L doesn't mean much. Length is okay, but it is still a little bit vague. And then you can see that the good choice would be side length, because that really spells out what your box, what your variable is. It's a length of it's a side. Or you can use the camel case, side, capital L, length. And side length at the bottom has got a space. That's a wrong. You can't do that. You can't have spaces. So name. So the first thing is name that your box needs, your variable needs. Then you need a value. And at this point, we can work with texts. So you can save your variable and give it a string. And you would do that. If you look down here, you got message equals hooray. And your string, if it's a string, it's got to be within quotation marks. And that then gives it the value of a string, and that then is saved into that variable called message. So you can see down here we've got message equals, so you set in it, giving it a value, and then hooray, it's my birthday. And then you could call that box at any time, and when you call it, it will print the content of that box. You can also give it a value, a number. So you could just do equals number. So you got pocket money using the underscore equals 20. So that there is just a quick overview. We haven't gone into too much of the other types. The other values. These are like the types that I'm focusing on today is string, int, and a float. And with Python, it does a real good job of guessing your variable type. And a lot of people use Python because it's easy and it follows the English language. And you don't have to think too much about some things. Like when I started with C++, when I was programming, and you have to state the type, int, and then the variable name equals, and you'd have to state the type. With Python, it tries to guess that for you. Sometimes it guesses it wrong. So this bottom thing here called casting, this is really important concept, because you can cast it to a certain type so that it doesn't get it wrong. As I've been using Python over the years, it has happened to me quite a few times where it's guessed the wrong variable type, and for some reason it thought that my integer was a string. So when I was doing an operation, it would give me an error. So that's where casting becomes useful. So you would do x equals and then cast, and then you give it the value. All right. What we'll do next then is we'll just quickly pop over to coding rooms, and we'll just quickly practice some of the things we were just discussing on variables and namings and stuff. So I'm on my coding rooms right now. I'm on my presentation mode, so you should be able to see me typing, and I can see your workspace if you want to join along. And I'm just going to type in some of the things that we were just talking about. So on the PowerPoint, we were using pocket money as an example. So the first principle we learned was that we give variables a suitable name. So you type pocket, and then I'm going to use camel case. So I would do pocket money. And I'm going to cast this because I'm going to hard code cast it to say this is always going to be an integer. So you would do equals, and then you'd put int for the casting, and then I would put, I'm going to have £20 pocket money. So you do 20. So that would then cast my pocket money, and it would give me an integer of 20. So let me just check if I don't know if John is still with us. John, are you still with us, or have you left us?
Well, it is time for beer.
You okay?
Yeah, I'm still here. Yes.
Okay. So we're just on coding rooms right now. We're just practicing some of those concepts we just learned about variables. Any questions on variables, or should we just move on to the next part? Yeah. Variables are quite an easy concept to understand, and as you get going with Python, it just becomes normal, really, and quite an easy concept. The next stage then is programming constructs. These are like the three constructs that are the fundamentals of programming. So you can have sequence, you can have branching, or you can have iteration loops, so controlled conditions. Let me just quickly talk through each different one. So a sequence is a set of code that runs line by line. So It's a sequence. Python will run from the top line. It would execute the line, then it runs the next line and the next line. That's called sequencing. So line 15 would print, line 16 would print, and line 17 would print. So that's called sequencing. That's a programming construct. The next construct is branching. And this here is used in Python to branch off and to run certain code to do with certain conditions. So I've got two examples here. I've got two if statements where I'm setting a variable called age equals 17. And then I've got a branch, two branches to say, if age is less than 18, then do this code. So print line 24. If age is greater than or equals to 18, then run this code. So it gives you an option. Do this or do this. So that there is called branching. The one underneath is a better way of doing this branching. So you've got age equals 20. If age is less than 18, run this code. And then you use a keyword, elif, which means else if. So if this or else if this. And then if none of those is triggered because of the condition, then you have an else. So do this or do this or do this. So that's that there is called branching. And then the last thing then is the iteration and the loops. And these are very useful for controlling your loops. So if you know how many times you want to do something, so do this 5 times and then carry on with the rest of the code. So there's 2 ways of doing that. I'm focusing on, we've got a while loop. So we could say if I equals 1, so I is set to 1, that's I is a variable. And then you're going to say while I is less than 6, so you're going to do this 6 times. And then you say print I, so you're going to print out I, which is currently 1. And then you're going to increment I. So every time it goes around this loop, I is going to increment. So it's going to print 1, then it'll increment by 1. So it'll go back around, then it'll print 2, then it'll print 3, then it'll print 4, then it'll print 5, and then it'll come back around and it'll say, while but I is now 6, so then it will not print the next one because it's got less than 6, and it'll fall out of this loop, and it'll continue then from line 35 down. So that's a conditioned loop. Very used a lot in programming. And also this for loop then is another way of looping. So you can say for X in banana and then print X. And what this does is after the word in, X will be for each one of those characters. So this is good to look at an example here. So I'll just quickly go to coding rooms and I'll just run that code for you really quick. I've got some here already made. There it is there. So I'll just paste that in here. And you can just see what happens. So down here you should be able to see it on your coding room, so you can watch my screen on Zoom. But it basically loops around. So for X in banana, X is firstly B, and then it's A, then it's N, then it's A, then it's N, then it's A. So it loops around, and X becomes each one of these strings, characters, these chars, and then it prints out the value X. So that there is another way of controlling your loops. Does anyone have any questions on that or want to see some other examples? Yeah, we're okay. All right. And this is probably my favorite part of Python, something that I think is actually, this is one of the first things I would teach my students is functions and procedures. I think once they understand how functions and procedures work, it really helps them with their programming skills as they develop. And and working out algorithms. So I'm just going to use coding rooms for this, and I'm just going to talk you through quickly about the difference between a procedure and a function and where they come into play in Python. So a procedure or a function in Python always starts with def. So you just say def, and then you give it a name. So you give your function a name, and a function or procedure is a piece of code that will get executed, so that will run when you call it. So I'm just going to call it my function for now. Oh, actually, let's give it a proper name. Let's call it an additional. Let's call it add, actually. Add. Just do add for simple. So my function is called add, and I am going to just add two numbers together. Now you can see that when I press enter, the cursor is indented, and in Python, it's sensitive to that indent. So if you write code under this function, it's usually set to 4, 1, 2, 3, 4, or you can just press tab is a quicker way, and then you can then write your code that runs when this function is going to be called. So I'm just going to say I am in the add function, and then if I run that, it's not going to do anything because I haven't called it. So I've created the function. Actually, I've created the procedure. I'll tell you the difference in a moment. I've created the procedure, and then I can then call it by just running add down here. And now I've called it, it will then call this function. So Python starts from line 1. It executes line 1, but it sees that it's a procedure, so it doesn't run it. It'll skip this. It will then skip this, and it'll get to line 4, and it will say, hey, you want to call this function, and then it'll go up here, and it will then print this. So if I run that, it should then print, I am in the add function. So it got to this piece of code, and then it run this function, this procedure. I keep going. So as you can see, I've just got the functions and procedure mixed up, and that's quite a common misconception in the programming world. And for teachers, I've got them mixed up quite a few times in lessons. But the difference between a procedure and a function is a function will always return a value. So it's only ever called a function if it returns at least one value. So right now you can see that my add function does not return a value. So this would be referenced as a procedure. It does something, but it doesn't return anything. So for it to be a function, you would then just say return, and then you can then return something. So I'm just going to say return true right now. And then let's just finish off with parameters and arguments. So right now this function is pretty rubbish. Garbage, as you would say in America. It's pretty garbage, and it doesn't do much. So this is then where I would then teach the students about parameters and arguments. So my function, because it returns something, so this is now a function, I need to give it something, because that's the whole point of this add function. It needs to add two numbers together, two variables. So in the brackets, the parentheses, you would then add here the parameter names. So I'm going to say num1 and num2. So this function is expecting, when I call it down here, it's now expecting two numbers, num1 and num2. And then in here, I can then say total equals num1 plus num2. So total will become those two added together, and then that variable will become total. And then I could then, instead of returning true, because that's no use right now, I would then just return total. And then down here, when I call the function, I would then give it two arguments. Now, I've used two keywords there. Up the top for the function, I called these parameters. So when you declare a function, these are referenced as parameters. When you call a function and you give it two values, they are called arguments. So that's a good thing to understand as well when you're teaching your students about Python and, well, actually any programming language. When you're referencing about parameters and what's an argument and what's a procedure, it's cross-board with all languages. So I would then give it two arguments, and I would give it 100, and let's give it 50. And right now, if I run it, it will just print out I am in the add function, because it's done it. It's sent these two arguments to the function 150. It's added it together. It's returned the total, but now it's looking. So when I called it, because it's returning total, it's looking for something. So the way you do this in Python is, before you call the function, you give it another variable that you equal to the function. So it says, hey, I'm looking for something. So I'm going to call this the total. Let's call it the sum. Sum equals the, oh, actually I can't use sum because that's a keyword, sorry. So total sum equals add. So now it's saying whatever this function returns, save it to the total sum. So if I run that, oh, I got printed as well, of course. So I'm going to print it as well. So print total sum, and then my output should give me the total sum. So 150. So you can see then 150 has been outputted there. All right, just a quick recap of that. Functions return a value. I've declared the function by using def. I've given it two parameters. I've then added the two parameters together and saved it to the total variable. And then I'm returning the total, which gets saved to the total sum, because that's where the function gets called. And then I'm printing the total sum. So that's like the basics of using a function, using a return, and how you call a function. So any questions on that? Okay. So that's kind of it. I was going to get you all to like expand on this and create some other functions yourselves, and to do like a subtract function, and we were going to create a calculator, like it's a simple one. We've only got 5 minutes left, and I'm quite happy just to take any questions or help you with any other Python questions you have, or I do have a bit of time if you do want to stick around, and I can talk you through some other stuff if you want. It's entirely up to you. But again, thank you for joining, guys, and hopefully you've learned something from the session.